Infinity. The word itself evokes a sense of awe and wonder. It represents something boundless, without end, a concept that stretches beyond our human comprehension. We can easily grasp the idea of large numbers, like 1,000,000 or 1,000,000,000. But infinity? That's a whole other ballgame. Think of the largest number you can imagine. Now imagine adding one to it, and then another and another, endlessly. That's the essence of infinity, a concept that defies our attempts to define it with boundaries or limits. But how does infinity apply to the vast expanse of the universe? Is it possible that the cosmos we inhabit, with all its stars, galaxies, and mysteries, stretches on forever? Or does it have an edge, a boundary beyond which nothing exists? These are questions that have captivated astronomers, philosophers, and curious minds for centuries. Join me on a journey to explore the mind-blowing concept of an infinite universe. We'll delve into the latest scientific discoveries, examine the evidence, and grapple with the profound implications of a cosmos that may be truly boundless. In the 1920s, astronomer Edwin Hubble made a groundbreaking discovery that revolutionized our understanding of the universe. Using a powerful telescope, he observed that distant galaxies were moving away from us, and the farther away they were, the faster they seemed to be receding. This discovery led to the theory of an expanding universe. Imagine baking a loaf of raisin bread. As the dough rises, the raisins, representing galaxies, move farther apart from each other. Similarly, the space between galaxies is expanding, carrying them along for the ride. This expansion is a key piece of evidence in the puzzle of the universe's size. If the universe is constantly expanding, does that mean it had a beginning? And if it had a beginning, does it also have an end? The expansion of the universe also introduced the concept of a Hubble horizon. This represents the limit of our observable universe, the farthest we can see back in time and space. Light from beyond this horizon hasn't had enough time to reach us since the Big Bang. But here's the mind-bending part. The universe might extend far beyond what we can currently observe. The Hubble horizon is constantly expanding as light from more distant regions finally reaches us. This means that the universe could be vastly larger than what we can currently see, perhaps even infinite. The shape of the universe is another crucial factor in determining whether it's finite or infinite. Imagine a flat sheet of paper. You could keep drawing on it forever, and it would theoretically extend infinitely. Now imagine that same sheet curved into a sphere. It would have a finite surface area, even though you could keep traveling around it without ever reaching an edge. Similarly, the universe could be flat, extending infinitely in all directions. Or it could be curved, like a sphere, positive curvature, or a saddle, negative curvature. The shape of the universe depends on its density, the amount of matter and energy it contains. Current observations suggest that the universe is remarkably flat, or very close to it. This flatness is a mystery in itself, as even slight deviations from perfect flatness would have resulted in a vastly different universe today. In the late 1990s, astronomers made another startling discovery. Not only was the universe expanding, but this expansion was accelerating. Something was pushing the universe apart, acting like a cosmic anti-gravity force. Scientists dubbed this mysterious force dark energy. It's thought to make up about 68% of the total energy density of the universe, yet we know very little about it. Its presence has profound implications for the fate of the universe and its size. If dark energy continues to drive the universe's accelerated expansion, it could eventually lead to a big rip. In this scenario, the expansion would become so rapid that it would tear apart galaxies, stars, and even atoms themselves. The concept of dark energy adds another layer of complexity to the question of the universe's size. If the expansion is accelerating, it further suggests that the universe could be infinite, Section 5. Echoes of the Big Bang. The Cosmic Microwave Background. About 380,000 years after the Big Bang, the universe had cooled enough for atoms to form. This event released a flood of light that has been traveling through the cosmos ever since. Today, we detect this ancient light as a faint glow known as the Cosmic Microwave Background, or CMB. The CMB is a treasure trove of information about the early universe. It provides insights into the conditions shortly after the Big Bang and helps us understand how the universe evolved into what we see today. Analyzing the patterns in the CMB, scientists have been able to determine the age, composition, and geometry of the universe with remarkable precision. The CMB also provides clues about the universe's size. The patterns we observe in the CMB suggest that the universe is either very large or infinite. If the universe were finite and smaller than a certain size, we would see repeating patterns in the CMB, like seeing the same pattern on opposite sides of a patterned sphere. However, no such repeating patterns have been observed. Section 6. A universe of multiverses? Exploring the possibilities. The concept of a multiverse takes the idea of an infinite universe to a whole new level. Instead of one universe, the multiverse theory proposes that there are countless other universes, each with its own set of physical laws, constants, and perhaps even dimensions. While the multiverse remains a theoretical concept, it's supported by some interpretations of quantum mechanics and string theory. These theories suggest that our universe might be just one bubble in a vast cosmic foam of other universes. If the multiverse theory holds true, then the question of whether our universe is infinite might be somewhat moot. Even if our own universe were finite, it would be just one of countless others within the grander multiverse, which itself might be infinite. So, is the universe finite or infinite? Despite all the evidence and observations, the answer remains a mystery. There's no definitive proof to settle the debate once and for all. Some scientists argue that the universe must be finite. They point to the fact that the universe had a beginning with the Big Bang and that something finite cannot become infinite. Others maintain that the universe could be infinite even if it originated from a finite point. They argue that our understanding of space and time might be limited, and the concept of infinity might be beyond our grasp. The debate hinges on our interpretation of the available evidence and our understanding of fundamental physics. New discoveries and advancements in technology might shed more light on this cosmic puzzle in the future. While we've made remarkable strides in understanding the universe, it's important to acknowledge the limits of our current knowledge. We're still grappling with fundamental questions about the nature of dark energy, the validity of the multiverse theory, and the true size and shape of the universe. Our understanding of physics, particularly at the quantum level and in the extreme conditions of the early universe, is still incomplete. There might be new laws of physics, yet to be discovered, that could revolutionize our understanding of the cosmos. The quest to understand the universe is a journey of discovery, and with each answer, we uncover even more profound questions. The unknown is vast and mysterious, but that's what makes the pursuit of knowledge so exhilarating. Regardless of whether the universe is finite or infinite, its sheer scale and grandeur are awe-inspiring. The thought that our planet is just one tiny speck in a vast cosmic ocean, teeming with billions of galaxies, each containing billions of stars, can be both humbling and exhilarating. Contemplating the immensity of the universe can put our everyday worries into perspective. It reminds us that we are part of something much larger than ourselves, connected to the cosmos through the intricate web of cosmic history and the laws of physics. The quest to understand the universe is an ongoing journey, driven by our innate curiosity and thirst for knowledge. New telescopes, satellites, and experiments are constantly pushing the boundaries of our understanding, revealing new wonders and deepening the mystery. So keep looking up at the stars, asking questions, and exploring the cosmos. The universe is full of wonders waiting to be discovered, and who knows what mind-blowing revelations await us in the future. Perhaps one day we'll finally unravel the secrets of the universe's size and know for sure whether it stretches on forever or has a boundary to its vast expanse. But even if we never find the definitive answer, the journey of exploration and discovery will continue to inspire and amaze us.